So I was just looking through the screenshots of my phone and I found that I had saved this screenshot of my profile, and the reason why is because this is one of my favorite exoplanet systems, HR 8799. This is how you know I'm a nerd.
This is a fact or statistic that seems fake but is real.
The matter that you and I and everything around us is made of, this type of matter called baryonic matter, that's not only all of this, but every star we see in the sky and every galaxy we see in the sky, all of that is less than 5% of the density of the universe. Less than 5%.
This is SpaceTok that just makes your brain go.
Space is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down to the road to the chemist, but that's just peanuts compared to space. For example, if you were to scale down the solar system so that the Earth was a mile away from the sun, the Earth would be less than 6 inches across. That's like the size of a grapefruit, a mile away from the sun. And that's just the solar system, which is one of the smallest astronomical scales. Space is big. You got it. At the center of the Earth, the force of the gravity from all of the places on the Earth around you would be basically offsetting because the Earth is pretty much spherical, and so you wouldn't feel any net gravitational force. You would, in fact, be weightless if you could somehow live at the center of the Earth. This is one of my favorite exoplanet systems. So why is HR 8799 such a favorite of mine? Well, it is a multi-planet system that we have directly imaged for many years, so we can do this. This is just one of my favorite astronomical observational thingies ever. Ever. It's so cool. Also, these planets are in a special dynamical configuration called a resonance. And so as a dynamicist, I find that fascinating. So HR 8799 is a really fascinating system, and that is why I was so excited when I saw that it was my follower account. Also, I'm just excited because that's a lot of followers, and I'm so happy to have this big growing space community.
Okay, well, setting aside the question of whether or not a singularity is physically what's happening inside a black hole or whether it's just a mathematical construct, what's happening with a black hole is you have enough mass and a small enough volume that gravity takes over and it just contracts forever and ever into an infinitely small volume, aka a zero volume. So if you have a density, which is a mass over a volume, now you have zero volume, you're trying to divide by zero. That's bad in math terms. And it doesn't matter what the numerator is because anything divided by zero will give you this. And so you can have a black hole of any mass as long as it's compressed into a small enough volume that this starts to happen.
Yeah, not a lot going on around here lately. Let's just see what's behind this door. No, is there a better door around here maybe?
No. Okay. Seriously, no, we don't know because we can't know what's going on inside the event horizon of a black hole. But for that very reason, you could say that the event horizon is the physical size of a black hole. And in that case, what you want is the Schwarzschild radius. Now, every gravitational body has what's called an escape velocity. This is the velocity at which you need to be traveling to escape the gravitational pull of the object. On Earth, that's about 11 kilometers per second. Now, the Schwarzschild radius is the point around a black hole at which the escape velocity is equal to the speed of light. Now, since nothing can go faster than the speed of light, nothing can escape from beyond the event horizon. This is given by a formula of about 2gm over c squared. And for context, if the sun was a black hole, its Schwarzschild radius would be about 3 kilometers. And if the Earth was a black hole, its Schwarzschild radius would be about 9 millimeters. Oh, we haven't seen the edge of the universe. We can't. I mean, so here's the thing. We're limited by light travel time. So we can see the edge of the observable universe, but that's not the entire universe. In fact, the entire universe is probably much, much bigger than the observable universe. I don't know if there's actually a specific size. I've seen 7 trillion light years thrown around, which is about 250 times bigger than the observable universe. But basically, light can only travel at a certain speed, and the universe has a certain age, and so things that are far enough away, we would not have had time to observe yet. So no, we are not seeing the edge of the universe. We are seeing the edge of the observable universe as limited by light travel time and the opacity of the early universe, which gives us the cosmic microwave background.
Your trash, kid.